Okay, I think now I'm recording. Yeah. All right. Where's the title? Okay, it disappeared. Okay, yeah, here. All right. So let me give the definition of what's a probability distribution, and then I will give you a couple of examples, right? So let me first define what I mean by probability distribution. So in a probability distribution is so you are gonna assign that's an assignment of probability to each value of your variable x. So the probability distribution is an assignment of probability to each value of the variable x. So, for example, let's do an example, a very concrete example. Let's say we have a survey. So this is a survey. So so there is a boredom test. Okay, taken taken by let's say 20,000 people. Okay. And so let's say we have like boredom levels from 0 to 6. So we have like boredom levels. So the boredom levels, they go from 0 to 6. Like, so we have 0, level 1, level 2, 3, let's say 4, 5, and 6. So 6, let's say it's 6, that's like the highest. This is the highest tolerance for boredom. Okay. Anyway, so we have this test. So we have this boredom levels from 0 to 6. And so the survey, so the results are the following. Let's say we got the following results. So the results are the following. So first you have your variable x. So the variable x is going to represent the boredom level. Okay, so x, that's your boredom level. Okay, so x represent the boredom level. So the values of x are, so x can be 0, x can be 1, x can be 2, etc. So x can be from 0 to 6, right? So x can be, can be 0 or 1 or 2, etc. or 3 or 4 or 5 or 6. Okay, so here's your x. And so again, x represents the boredom level. So x goes from 0, then 1, 2, 3, 4, right, 5, and 6, right? Now you count. So for each boredom level, of course, you're gonna count how many people. So here, this is a number of people. This is a number of people. So let's say a number of people with boredom level equal to 0 is 1,400. Number of people with boredom level equal to 1 is 2,600 out of 20,000, right? Of course, the size of the sample, in total, we have 20,000 people, right? So Then with boredom level equal to 2, let's say we have 3600. With boredom level equal to 3, we have 6,000. With boredom level equal to 4, we have 4,400. And then 1,600 with boredom level equal to 5. And finally, the level boredom level equal to 6. Again, 6, that's like the highest tolerance for boredom. We have 400 people. Okay, so we don't have too many people with very
and all this number adds
yes.
to 20,000, right?
Yes. So the total, yeah, of course, total is the total of number of people here would be 20,000. Yes, of course. So the yeah, sure. So the total number people here would be 20,000. All right. So again, the idea here, guys. So you have this variable x, right, which represents the boredom level, right? So now, so what I'm gonna do, first before the probability distribution, let me just, for example, let's say you want to find, the probability of randomly choosing someone with boredom level equal to 4, for example. Find the probability of randomly, choosing someone out of the 20,000, of course, choosing someone with boredom level, boredom level, let's say equal to 4. Okay. So here in this case, when I say boredom level equal to 4, I mean my x. So my variable x is 4, right? Again, the x, this variable x, supposed to represent the boredom level. So my x is 4, right? So how do we compute such a probability, right? Any guess? What will be the probability of choosing someone with boredom level equal to 4 out of the 20,000?
Would it be 4,400?
Yeah, over, of course, over the 20,000.
The size of the sample.
Yeah, absolutely. Very good. So so probability that my x is equal to 4. So here, when I write x equal to 4, I mean boredom level equal to 4, right? This is x is 4. So then it means like my boredom level is 4. Okay. So probability of choosing someone with boredom level equal to 4, that will be, as Kayla said, the total number of people with boredom level equal to 4, which is 4,400. So we have 4,400 over, right? So this number here, the number of people with boredom level equal to 4 over the size of the sample. We have in total 20,000 people, right? Anyway, so we divide 4,400 by 20,000. That's 0.22, which is multiplied by 100, convert it into percentage. That will be 22%. Anyway, so the thing is, the idea here is, what I'm saying is, if my x is 4, so it's like, so here what I'm saying is, like, if x is 4, my boredom level is 4, then the probability that x is 4 is 22%. Okay. So what I'm doing here, so I'm assigning to the value x equal to 4 the probability x equal to 4, which is 22%, right? So here I'm assigning, so we are assigning to x equal to 4 the probability p of x equal to 4, which is 22%. Okay. So now let's come back to this probability distribution. So probability distribution is an assignment of probability to each value of your variable x. So now let's say you want to find your probability distribution of the variable x. So question, let's say you want to find the probability distribution of the variable x. Of the variable x. So what we need to do, guys, here, we need to find the probability of for each x. So of the variable x. Okay. So to answer this question, we need to find the probability of x for each value of x, for each possible value of x, for each possible for each value of x. Okay. So so we need to do the same thing for, so here we computed the probability that x is 4, for Boredom level is 4. So we need to do exactly the same thing for x equal to 0, all the values of x, right? So we have x can be 0, right? The variable x can be 0, can be equal to 1, can be equal to 2, etc. So we need to compute the probability of x for each value of x. So the answer would be like a table. So the probability distribution, so the probability distribution so the answer would be the following, actually. So it's going to be so it's given by a table. So we're going to have like a table here, and here in the top you have your x, which goes from the Boredom level, so from 0 to 6, 1, 2, 3, 4, 5, and then 6. And then in the next next row, we have probability of x. So for example, we are saying that if x is 4, the probability that x is 4 is 22%, right? So here in my probability distribution, I'm going to put 22% when x is 4. Okay. So now I need to compute, again, probability of x for each value of x. So that's what we mean by probability distribution. Probability distribution, that's your table where you assign for each value of x the probability of x. Okay. So we need to find, so to complete the table, of course, we need to find, so to complete the table, so we need to find, of course, the probability of x equal to 0, probability that the Boredom level x is 0. We need to find probability that x is 1, probability that x is 2, 3. So we did 4, so we can move to the 5 and then 6. Right? So we need to find the probability for each value of x, right? So for x equal to 0, so the idea is just the same, right? So you count how many people with Boredom level equal to 0. So here it's 1,400 out of the 20,000, right? So it's 1,400 over 1,400. So here would be 1,400 over the 20,000. So that would be, I think, 0.07, which is 7%. X equal to 1. I think we have 2,600 people with Boredom level
That
equal
was
to 1.
13%.
13%. So over 20,000. So that's 0.13. 13%. So I guess I need to mute someone. Sorry about this. I don't know who it is, but I'm sorry.
So Professor, so basically how we found the first answer is how we get all them answers.
Right. Yes.
Okay.
Yeah, that's how. Yeah, exactly. Yeah, exactly what we did for the first answer. Yes. I'm writing down the answers here. For x equal to 2. So we have 3,600, etc. So here it's 0.18, I think. So that's 80%. etc. I'm gonna just probably here write down etc. Okay. Now, so my probability distribution. So here for x equal to 0, we got 7%. Oops. Okay. So we got 7%. For 1, this is 13. For 2, this is 18%. For 3, it's 30%, I think. 5, the answer would be 8%. And for 6, that would be 2%, I think. So 2%. Okay. So this table where you assign for each value of x the probability of x, that's what we call the probability distribution. Okay. So when you hear the word probability distribution, guys, it means it's a table where you assign for each value of x the probability of x. Okay. So that's what we mean by probability distribution. All right. So before the next example or next exercise, let me just say here one remark about the variable x, which is kind of an important remark. But you see the variable x here, it can take on, the values of x, they go from 0 to 6, right? So the variable x here can take on only a finite number of values, right? So x here, just write down here this remark. So x, x can be x is 0, or x can be 1, 2, 3, 4, or 5, or 6. So that's a finite number of values, right? So x here, x can take on only a finite number of values, right? So from 0 to 6, we have like how many values, how many possible values? Well, 1 value, 2 values, 3, 4 values, 5, 6, 7 values. So there are like 7 possible values over x. So that's a finite number, right? A finite number, by finite number, guys, I mean, it's not infinite, all right? It's a finite. So in this case, we say that x is actually a discrete variable. So we say that x is a discrete variable. Okay. So the new terminology here is the word the discrete, right? The discrete variable. So again, discrete variable means that the variable can take on only a finite number of values. Okay. Later we'll see examples where your variable x can take on any value, not like finite number of values, but can take any value in like an interval. Okay. Anyway, so that's this table again, that will be the probability distribution of my variable x. And of course, in this case, I can actually graph the histogram of this probability distribution. So we can here, so next, so let's graph the histogram of the probability distribution. Okay. So what we do here is, so like, the histogram, we have the horizontal axis. So that will be actually the variable x. So this is the variable x. So our x can be 0, can be 1, 2, 3, 4, 5, and 6, right? That's the possible values of x from 0 to 6, right? And then on the the vertical axis, we're gonna have the probability of x. So here on the vertical axis, that's the probability of x. So that's p of x. Okay. So again, so there is the horizontal axis. So the horizontal axis, you have the values of x. And on the vertical axis, you're gonna plot the probability of x. So this is the probability of x, or p of x, capital P of x. Okay. So for example, so what we do is, if x is 0, right? If x is 0, the probability of x is 7%, right? So what we do is, so here is, so let's say the probability of x here, so we have 7%, 13, 18, 30, 22, 8, and 2%. So the smallest p of x is the 2%, right? Or 2% or 0.02. So let's plot the 0.02 or the 2%. So here I have this is so my 2%, right? Which is again just a 0.02. We have 7%. So let's say this is like my 7%, which is 0.07. And then the next probability of x, I think we have 8%. So here is my 8%, which is 0.08. Then the next we have probability of x is I think the 13%. So this is my 13%, which is 0.13. Then we have 18%. So 1, 2, 3, 4, 5. So this is 18%, which is 0.18. And finally, the largest probability of x is, I think when x is 4, that's 22%. So that's this is 22%. So this is 0.22. Anyway, so for example, when x is 0, the probability of x is 7%, right? So what we do is we take we take an interval where the 0 is the middle of the interval. So like here, you see in this interval, this is a blue interval. So my 0 is like in the middle of the interval, this blue interval. And then we're gonna draw like the box or rectangle with the height equal to the probability of 0, which is 7%. So we need to go up to 7% here. Okay. So this represents the probability of x equal to 0. Next value of x, it's 1. And the probability of x is 13%. So I'm going to take the interval with 1 in the middle of my interval, right? So 1 is the middle, and I'm going to go up to 13%. So right here. Okay. Etc. So then the 2%, sorry, x is equal to 2. The percentage is 18%. So here's my interval, which represents x equal to 2, right? Again, the 2 is like in the middle. And then we need to go up to 18%. So the height of the box here, or rectangle, is 18%, 0.18, etc. So let me just finish here. Next, we have C with the, oh, did I forget the 30%? Oh yeah, I forgot the 30% actually. Sorry, there's the 30%, right? 0.30. So when x is 3, yeah, the probability is 30%. So yeah, so here's my x equal to, oops, So here's my x equal to 3. Take 3, so your 3 is in the middle of your interval, and we need to go up to 30%. X is 4, the probability is 22% or 0.22. So we need to go, so here's my 4, and we need to go up to 0.22%. So that'll be right here. 5. So when x is 5, the probability that x is 5 is 8% or 0.08. So here's my 0.08. Again, 5 is in the middle. Your x is in the middle of your interval. And then the height of your rectangle is given by the probability of x, so 8%. And finally, for 6, the probability that x is equal to 6 is 2% or 0.02. So 6 in the middle, and then we go up to 0.02. Okay. So this histogram, this is the histogram of my probability distribution, right? So this is a histogram. So this is, so this histogram represents our probability distribution. So again, guys, just keep in mind, when I say a probability distribution, means for each value of x, you assign a probability, right? For each x, value of x, there is a corresponding probability, okay? Any questions so far? Let me see the chat. Okay, no questions. All right, so before the exercise or the next example, let me just say one thing here, guys, which is kind of important. The sum of all the probabilities here, if you take you take this 7% plus the 13% plus the 18 plus 30 plus 22, etc., plus 8 and plus the the 2%. The sum of all the probabilities is always, it has to be equal to 100%. Okay. So the sum of all the probabilities, right? The sum of all the, just a remark here. Remark. So the sum oops, remark. So the sum of all probabilities is 100%, which is of course 100%. That's like 100 over 100%. It's like division by 100. So that's equal to 1. Okay. So in other words, again, what I'm saying is if you do, probability that x is equal to 0 plus probability that x is 1 plus probability that x is 2 plus probability that x is 3 plus probability that x is 4, etc. 5 and then 6, right? And 6, that's the highest boredom level. Here 6. So the sum of all the probabilities is 100%, which is 1. Okay. So in other words, guys, the area here in the histogram, the area under the graph, you have this. So here, this histogram. So we have this graph. If you take just the this graph right here. Okay. So then the area under the graph would be equal to 100%, would be equal to 1. Okay, so the area under the graph is equal to 1 unit, is 100%. and that's 1 unit square. Okay. And that's again, it's just because the sum of all your probabilities is equal to 100%. Okay, so yeah, so what I'm saying is here, like you have your histogram, you know, this is your histogram, etc. Right? So what I'm saying is, you see the area here under the graph, the area here would be equal to 1, always equal to 1, is 100%, that's 1. Okay. So let's say this is your histogram. All right. Okay, so let's move to so we can probably do an exercise, or let me see if there are any questions. Okay, no questions. Okay, cool. All right, so which value of x a probability, right? Now, so we're gonna have an exercise, and then after that, we're gonna compute like the mean, like you know, the average and the standard deviation of a probability distribution. So, but let's do an exercise first, okay? So let's do the exercise we can do an exercise from the textbook, I guess. So this is an exercise from the textbook. So let's say exercise 13. So this is exercise 13, page, I mean, if you have the textbook, that will be page 254. Okay. So in this exercise, there is a variable x. So the variable x represents the number of fish caught in a 6-hour period. So this is the number, x represents the number of fish caught in, say, a 6-hour period. And so the p of x, well, so we have the following. We have let's say let me see how many fishermen. So we have, like, let me see. Okay, yeah. So let's say we have the following. We have 100. So let's say we have 100 fishermen. Okay. And so we have the following. Results. Okay. So x, that's the number of fish caught in a 6-hour period. So let's say here x can be 0, 1, we have 2, 3, and then 4. Okay. And then we have the number of fishermen. Okay. And so of course the size of the sample is 100, right? In total we have 100 fishermen. And so let's say we have 44. There's 44 fishermen who caught 0 fish in a 6-hour period, and then 36 fishermen who caught just 1 fish, and then 15 fishermen who caught 2 fish, and then 4, and then just 1 fisherman who caught 4 fish in a 6-hour period. Okay.
Excuse me, I have a question.
Yeah, please.
How do you have for x? How do you only have 4?
I'm just we're just saying the 4 is like that's the maximum number of fish caught by the fishermen here, by the 100 fishermen here.
Okay, that the problem says that?
Yeah, just a
Oh,
problem says
okay.
that. Yeah.
Okay.
Of course, you can have like different problem where where your fishermen they would caught like catch like more than 4 or something. But let's say in this problem, the best fisherman he actually caught just 4. Yeah, 4 fish. All right, so the first so question 1. So you need to find. So please try to find the probability distribution of this x. Find probability distribution of x. Probability distribution of the variable x. Two, you need to graph. Let's say graph the histogram of the probability distribution. Probability distribution. Anyway, so the point here, guys, is that you understand this notion of probability distribution, right? So you understand that this probability distribution, that's an assignment for of a probability for each value of x. Okay. Okay, so I'm gonna just give you a couple of minutes to think about this. This is a kind of I think straightforward, but yeah, just give you a couple of minutes to think about this. So you need to find, when I say find probability distribution, you need to make the table value with the variable x, and then the probability of x for each value of x. See if there are any questions in the chat. Okay.
It's basically the same numbers, just percent.
Yeah, just percent. Yeah, and yeah. So yeah, thank you. So yeah, guys. So yeah, so here just the idea is to know that probability distribution would be, so the so your probability distribution would be the following table, where you assign for each x probability of x, right? So you're gonna have, so this is x. X goes from 0 to 4, so 1, 2, 3, and then 4, and then next row, we have the P of X, probability of X, right? So you just divide, to find the probability of X, for example, we want to find probability of like X equals to 0. So you count how many fishermen who caught like 0 fish, right? In this 6-hour period. So we have 44 fishermen, right? Out of the 100, right? So it's 44 over divided by 100, right? Which is, of course, just 0.44, which is 44%, right? So the probability that X is 0, right? Probability that a random fisherman catches like 0 fish is 44%, right? So this is, so probability of X equal to 0 is, this is 44%. And just let me just remark here, guys. So the 44, that's the frequency of the event, right? That's the number of fishermen who caught like 0 fish. That's like a frequency, right? That's, I mean, that's just the formula of the probability. And the 100%, that's the size of the sample, right? And remember when we discussed the frequency tables, we said the frequency over the size of the sample, that's what we call relative frequency, right? This is a relative frequency. Just a relative frequency. So this probability is just the relative frequency, right? And yeah, so this is for X equal to 0. We do the same thing for X equal to 1. So it's just, so we have 36 fishermen who got just 1 fish. So the answer would be, of course, 36%, etc. So here is, I think it's 15%. Then we have 4 out of 100, so that's 4%. And then we have 1 out of 100, so that would be 1%, right? And then the histogram. So remember, again, I mean, when we discussed the frequency tables, the histogram is supposed to display either the frequency or the relative frequency. So in this case, our histogram, of this probability distribution is just, the histogram of the displaying the relative frequency. So the histogram would be, so the only difference with the frequency tables, so in the frequency tables, we use the classes boundaries. So we have like intervals, but here we don't have intervals. Here we have like a finite number of values of X, right? We don't have intervals. We don't have classes here. We have some values of X, right? So anyway, so yeah, for the histogram, the horizontal axis, that would be your X axis. So here we have 0, 1, 2, 3, and then 4. Vertical axis, that's your probability of X, that's your relative frequency, in other words. And so we have these values of probability of X. So the smallest one is 1%, right? Which is, of course, 0.01 if you want to use decimals. Then we have 4%, 4%. Then there's 15%. Then we have 36%. And then we have 44%. Anyway, so again, just to remind you how to draw this histogram. So for the 0, you take the interval with the center equal to 0. And so the probability of X equal to 0 is 44%. So we need to go up to 44 here. This is 44%, right, etc. Next, we have 36. So here's 36%. Next, we have 15. So we take an interval with the center of the interval equal to 2, and then we need to go up to 15%. Then 4%. and then finding the 1% with x equal to 4. So last x is when x is 4, and the probability of x would be 1%. All right. Any question, guys? See the chat. Okay. Oh, okay. There are some questions in the chat, I think. Let's see. Oh, yeah. You need some same steps. Kayla, you have the trouble with the Wi-Fi. Yeah. Nope. Sorry about that. Yeah, sure. No problem. You can review the video later. Yeah, sure. All right, so next, guys, we're going to compute the average or the mean of probability distribution and the standard deviation of the probability distribution, right? So next, mean or average, mean, and well, let's start with the mean of a probability distribution. So that's like the average of your probabilities, right? So, so this probability distribution, so you have so suppose you have a variable x. So x is the variable. It's a discrete. X is a discrete variable. Okay, and you have a p of x, capital P of x. That's the probability of x. Probability of x. Probability of x. All right. Then the mean. So we have the mean. So the sample mean. The mean of this probability distribution of the probability distribution x bar. Probability distribution. So x bar is going to be equal to, so x bar, right? Again, x bar, that's a notation for the mean, right? That's a notation for the mean. X bar is going to be equal to x, sum of x times P of x. So you multiply each value of x by its corresponding probability, right? So this is, so x, this is your variable, and the P of x, that's the probability of x. So this mean is actually, this is a sort of a weighted average. Remember in the weighted average, so you multiply, each value of, each value of x by its corresponding weight. So the P of x, this is like the weight of the weight corresponding to x. This P of x here, this is like the weight of x. Okay, so this mean here actually corresponds to the, it's just another version of the weighted average, but for probability distributions. Okay. So in our example, oops. Yeah, just let me just write down here a remark. So this x bar, so the mean of the probability distribution is the mean of probability distribution is just a weighted average, where the weight corresponds to the P of x, probability of x. The mean of a probability distribution is just a weighted average. Is just a weighted average where the P of x, where the weight is equal to the P of x. Weighted average where the weight is actually, the weight of x is P of x. Okay. Yeah, so for example, let's do the example here. So for example, So for example, I'm gonna just use the previous example with the number of fish X. So we have this, this table. So X here again. So X, this is the number of fish caught, and the P of X, of course, that's of course this is a probability of that random fisherman catches X fish. Okay, so for example, if X is 2, P of X, that's probably that the random fisherman catches like 2 fish, etc. So we have this table, right? The values of X. So we have this table where, X is like 0, then, 1, then 2, then 3, and then 4. And then we have like probability of X, for 0, we got 44%. For 1, we got 36%. For 2, that's 15%. When X is 3, I think we got 4%. And when X is 4, we got 1%, right? Let's say I want to compute the mean of this probability distribution, right? So let's say, the question here, question, let's compute the average or the mean, compute the mean of this probability distribution, So, so in this case, X bar, so you multiply each X by the corresponding probability, right? So you take first values of X, of course, is 0, right? And the corresponding probability is 44%. So we multiply, so it's like 0 times 44%, okay? Plus, and then next value of X is 1. So it's like plus 1 times 36%. Okay. So next value, of course, is 2 times 15%, right? So it's plus 2 times 15% plus 3 times 4% plus 4 times 1%. Okay, so then X bar is equal to, 0 times, so we do multiplication first, of course, multiply. 0 times 44%, that's just 0, plus 1 times 36%, so it's just 36%, plus 2 times 15%, which is 30%, plus 3 times 4%, which is 12%, plus 4 times 1%, that's 4%. Okay. So then X bar, it's 36%, 36, 0 plus 36% plus 30%, plus 12% plus 4%, right? And the answer, I think, is 82%, which is, so if you want to convert this into a decimal, 82%, of course, that's 82 over 100, which is 0.82. Okay, so X bar here, so what we are saying here is that X bar is 0.82. So what does this number mean for us? What will be another interpretation of this number? So what does it mean for X bar to be equal to 0.82 in this problem? Well, so what we are saying is, so a random So what we expect here is that a random. So if you select a random fisherman, then the fisherman would catch I guess 0.82 fish in a 6-hour period. All right. So what we are saying here is that we expect that a random. So when you select a random fisherman, we expect that a random fisherman catch, let's say 0.82 fish. Okay, it's not well, it's close to one fish, right? But that's what we expect. So if you select any random fisherman, you expect that the fisherman would catch like 0.82 fish. Okay, that's like the average number of fish, the average number of fish caught by the fisherman here. Okay, so that's like the interpretation of this number, of this answer. So that's what means the 0.82. Okay, so again, you always think of the X bar, the mean. That's like always the expected number. You select a person at random, so the X bar, that will be like the expected number. So here we are talking about the number of fish caught by the fisherman, right? So then the mean, that's like the expected number of fish caught by a random fisherman. Okay. Does this make sense to you guys? So that's what we mean by the mean of this probability distribution in this problem, of course. So all you have to do, guys, to compute the mean of a probability distribution, as I said, just take you multiply each value of X by its corresponding P of probability of X, okay? And take the sum, right? That will be your X bar, the mean of your probability distribution. Any questions so far, guys, for the mean? So it's once you have your probability distribution, right? Once you assign for each X the probability of X, to compute the probability, the mean of the probability distribution, you just have to multiply each X by the corresponding P of X. Okay. All right. So that's for the mean. Okay. So before the exercise, let's do the standard deviation, right? So we have the mean, and we have also the standard deviation of a probability distribution. So next, so we have the standard deviation of a probability distribution. Okay. So again, so in this case, your X is a discrete variable, of course. So here X is a discrete variable. And P of X, of course, that's the probability of X. Probability of X. All right. So what will be the standard deviation of your probability distribution? Well, so first you have the variance S squared. So first, the variance S squared. So they'll be equal to. So what we do is, so we take the sum of X minus X bar, the mean, the square. So this is like a distance. The square here means like that's like the square of the distance between your variable X and the mean X bar. but then we'll multiply by P of X. So here multiplication by P of X. So again, this formula means this is actually, so this is actually the, you know, the like weighted, the weighted version of the distance from your variable X to the mean. So this is like the weighted distance from X to X bar, from the variable X to X bar. So the weighted, of course, the weighted average. This is the weighted average distance. So weighted average distance from the variable X to X bar. From X to X bar. And then, of course, the standard deviation would be just the standard deviation would be just the square root of S squared. S, just the square root of S squared. And again, the idea here, guys, the standard deviation, it's useful because you can measure the spread of your probability distribution. Okay, so later you'll see we're gonna compare probability distributions. So we're gonna use this standard deviation to measure, you know, the spread of your probability distribution. So, well, so for example, so let's do an example. So we can do the we can do different example, or we can just use the same examples as the previous examples. Well, we can do different example. So this is, so X here in this example represent, so X is the number, this is the number of prisoners out of 5, number of prisoners, say, out of 5 who become repeat offenders. So it's out of 5. So the maximum, so the largest possible value of X would be 5 repeat offenders, of course. Okay. So we have the following probability distribution. So we have the following probability distribution. So here, there's your X, that's the number of prisoners out of 5 who become repeat offenders. So there's this your X here. So out of 5, so X can be 0, X can be 1, can be 2, can be 3, can be 4, and can be 5, okay? Now, next we have probability of X. So that's the probability of the, like, if X is 0, probability that X is 0, that's probability that zero prisoner out of 5 who become repeat offender, right? So this is, so let's say for 0, P of X is, let's say 0.237, okay, which is 23.7%. For 1, it's 0.396. For 2, it's 0. Let's say 264. For P, it's 0.088. For 4, 0.015, and for sorry, for 4, yes, and then for 5, it's 0.001. So for example, again, so what I'm saying here is, so for example, probability that X is 1 is 0.396, right? Here's the probability that X is equal to 1, right? Which is, again, 0.396 converted into percentage, multiply by 100, that's 39.6%, right? So what we are saying is there is 39.6%. So what we are saying is there is 39.6% chance. So there is 39.6% chance that one prisoner, for example, one prisoner out of five who become a repeat offender, right, etc. So that's our probability distribution. All right. So the question is, so I want to compute. So the question, so first we need to find the X bar, the average. So find the sample, the mean of the probability distribution. The probability distribution. Okay. 2, find the standard deviation of this probability distribution. Of the probability distribution. Okay. So I'm gonna give you a couple of minutes, guys. You can at least, I guess, you can probably try to compute number 1, the mean of the probability distribution. Just to remind you the formula. So for number 1, the mean X bar, the formulas here. So X bar, we said it's just a sum of X times the P of X. Okay. For 2, the standard deviation. Well, first you need to compute the variance S squared, which is actually X minus X bar square times the P of X. And then S, the standard deviation, will be, of course, square root of S squared. All right, so I'm gonna give you a couple of minutes to think about number 1 and number 2, if you can, if you know how to apply the formula. So this is example, actually, that's exercise 14, page 255 from the textbook. So this is actually, this example, this is exercise 14, page 255 from the textbook. Let me see the chat if there are any. Okay. So, does anyone has the answer for the mean of this probability distribution? I'm gonna check the chat. Okay. Okay, guys, I mean, we have like 4 minutes. So I'm gonna go over number one, and I guess tomorrow we'll discuss number two. So for number one, to find the, oops, yeah, you wanna find the mean of the probability distribution, right? So the mean, sample mean of the probability distribution. So so x bar, right? We said it's just a sum of x times the corresponding probability of x, right? X times p of x. So first x in the table is 0. So then we need to multiply 0 by the corresponding probability of 0, which is 0.237. So we have like, so we're gonna have like 0 times multiplied by 0.237. That's the probability of 0. plus next x is 1. So times 0.396 plus next x is 2. Corresponding probability is 0.264 plus next x is 3 times 0.088. Next x is 4, right? And then corresponding x is corresponding probability is 0.015, right? When x is 4, corresponding probability is 0.015. So that's times 0.015 times 0.015 plus next x is 5, and the corresponding probability is 0.001. So we do multiplication first, right? We multiply first, right? PEMDAS rule, multiply first, and then we add, right? So like here, we do the multiplication 0 times 0.237, that'll be 0. Plus, you know, you do 1 times 0.396, so that's 0.396, right? Etc. Plus next 2 times 0.264, so that will be 8 2 5, so it's 0.528 plus there is of course 3 times 0.088, right? So that will be
264.
Yes. Yeah.
264.
Yeah, 264. Thank you. Plus that's 4 times 0.015. Just be careful with the zeros here because there is another 0 after the decimal point, right? So that's 0.06 or 0.60. So 0 plus 0.060 plus 5 times 0.001. So there are like 2 zeros after the decimal point. Just be careful with that. So this is actually 0.005. And I think the answer would be 1.253, right? This is 1.253. So now, what does it mean, this number? What does it mean for x bar to be equal to 1.253? So here, the x is supposed to represent, where is it? X, that's the number of prisoners out of 5 who become repeat offenders. That's your x. So then x bar would be the expected number of x. So what do we expect, right, is that we have 1.253 prisoners out of 5 who become repeat offenders, right? So we expect, let me just write down here. So this number means that we expect that 1.25 prisoners. Well, I mean here, of course, I mean 1.25 prisoners doesn't mean there's no such thing as 25.25 prisoners, right? But let's say it's a number which is kind of close to 1. So we expect like at least 1 prisoner out of 5 who become repeat offenders. Okay. So anyway, so what I'm saying here, guys, so what you need to keep in mind is when we talk about mean, that's the expected number of x. This is the expected number of x. Expected number of x. Wherever x is, okay? All right, guys, I'm gonna stop here. So tomorrow we'll discuss the standard deviation in more details, okay? And then probably I'll do one more exercise, and then we can move to the next section. All right, thank you, everyone. Thank you for listening. And
Professor,
yes, please.
I'm sorry. And what page number I can find more exercise?
Well, you know, the syllabus. If you check the syllabus, like the last page in the syllabus, there is a list of suggested problems.
Okay.
So like here for this is section 6.1, right? So I think if you check the syllabus, I don't have the syllabus, but it's supposed to be like in like pages from 253 to 255, I think. But yeah, do you have the syllabus? So if you do have the
Yeah.
syllabus, just check. Yeah, check the last page. You
Yeah.
can find that. So this is section 6.1. All right, guys. Thank you for listening, and hopefully I'm gonna see you tomorrow. Take care, everyone.